Aloha. Today we're going to talk about angle relationships. I'm going to try to get through this as quickly as possible to keep this video nice and short. So if you get lost or if I move too quickly, pause, rewind, and rewatch. Okay? Adjacent angles. The word adjacent literally means right next to. So if I have adjacent angles, those are two angles that have a common vertex and a shared side, but they do not overlap. What does that mean? Let's draw a diagram to illustrate. So here I have an angle right here. Okay, I'm going to label these. Angle 1, angle 2. Angle 1 and angle 2 are adjacent angles because they have a common vertex, which is right here. And they have a shared side, but they don't overlap. What they're trying to say is that shared side has to be the side that's between them. They don't overlap. The side they share is in between them. So there's my shared side. Angle 1 is adjacent to angle 2. They have a shared side. Linear pair. Folks, look at the word. First off, it's a pair, so it's like sneakers, okay? You have to have a pair. Just two, and if you look at the first word, it literally starts with the word line. So if I have a linear pair of angles, those are a special type of adjacent angles. They are adjacent angles, but their non-common sides are opposite rays. So yes, let me draw another diagram for you. Watch this. So I have an angle right here. Right? I want to draw one adjacent to this, but the non-shared side is in the opposite direction. So notice I have this side here. This is going to be my shared side right here. So the non-shared side has to go in the opposite direction of this side, like this. Oh, look at that. If I label these, 3 and angle 4. Angle 3 and angle 4 are a linear pair because their non-common sides form a straight line. Linear pair, line. Vertical angles. They are non-adjacent angles formed by intersecting lines. So let's start with that. Let's draw some intersecting lines. Angle 5, angle 6, angle 7, angle 8. So now I have 4 angles formed by these two intersecting lines. I want the vertical angles. They are non-adjacent. So if I said angle 5, what angle is not right next to angle 5? Well, let's take a look here. Angle 5 and angle 6, right next to each other. They're adjacent. Angle 5 and 8, they're adjacent. They're right next to each other. Well, look where 7's at. 7 is right across from angle 5. So angle 5 and angle 7 are a pair of vertical angles. Also, 6 and 8 are vertical angles. Angle 6 and angle 8. Okay? If you're sitting at lunch table and there's 4 of you at the table, okay? If you're sitting here, this friend is adjacent to you. He's right next to you. 7, the friend sitting across the table from you, he's sitting vertically. He's vertically straight across from you. So those are vertical angles. They're right across from one another. More relationships. Complementary angles. No, complementary angles are not angles that walk into the room and say, hey, you look very nice today. I like your outfit. Wrong kind of compliment. In geometry class, complementary angles are two angles that add to 90 degrees. Now it's just two. Complementary angles are just like the other ones. They have to come in a pair. So just two angles. For example, if I had this angle here, and my measurements aren't going to be exact because I'm kind of winging this here. If I had this angle here, and I were to give these measurements, 30 degrees, 60 degrees. 30 degrees and 60 degrees are complementary angles, because if I take 30 degrees plus 60 degrees, I would get 90 degrees. Those are complementary angles. Supplementary angles. Now the definition for supplementary is almost exactly the same as complementary. Matter of fact, it's the same all the way up until here. Complementary angles add to 90 degrees. Supplementary angles add to 180 degrees. So let's draw another quick example here. Again, my pictures are not drawn to scale. Not in the slightest. So if I were to hypothetically say that this angle is 125 degrees, and this angle is 55 degrees, 125 degrees would be complement or supplementary to 55 degrees, because if I add them, they equal 180, supplementary angles. Perpendicular might be a word you saw before. Perpendicular lines, segments, rays, planes, anything can be perpendicular. To be perpendicular, you have to form right angles. So, I'm going to draw some lines. Now, previously you might have seen this before when dealing with algebra and you were doing graphing. These look like the x and y axes. The x and y axes are perpendicular to each other. These lines, however, right now, I would not consider these perpendicular. There's one key thing missing. Remember, they have to form right angles. Well, in order for me to know I have a right angle, they have to tell me I have a right angle, or again, they have to show you on the diagram with that little box in the corner. That means right angle. So now these lines are perpendicular. If I were to give them names, line L and line M. If I want to say line L is perpendicular to line M, perpendicular is a very big word. I want to cut that down. I want to make it as short as possible. Here's what I'm going to write. I'm going to write line L is perpendicular to line M. If you see this symbol here, it's not a typo from the typewriter. An upside down capital T means perpendicular. This right here would state line L is perpendicular to line M. That is perpendicular. Example 1, I got this weird looking figure over here, but simply they want me to find the complementary angles, they want me to find supplementary angles, and they want me to find adjacent angles. So I'm going to do just that. So I'm going to start off at the very beginning with complementary angles. I'm going to look at that diagram, and I'm going to ask myself, since there's some measurements up there, are there any numbers here that add to 90 degrees? In fact, there is. 52 plus 38 is 90 degrees. So what are those angles? Remember, we need 3 letters to name them most of the time. So if I'm naming the 52 degrees, that is angle ABD. So angle ABD is complementary to angle CDB, the 38 degrees. That takes care of my complementary angles. Now, let's get rid of our notations here and we'll try to find supplementary. Supplementary angles add to 180. Are there any numbers on that diagram that add to 180 degrees? Yes, 52 plus 128. Now, the nice part about this, I already know the name for this 52 degrees because we named it in the complementary. That's angle ABD. Angle ABD is supplementary to angle DBDE. BDE. Okay? That takes care of my supplementary angles. Get rid of these. And now we're going to look for adjacent angles. Now adjacent angles, there's nothing special about their measurements. They're just 2 angles that are sitting right next to each other, hanging out, all right? They're just chilling. So, do I have a pair of angles right next to each other? Yeah, the 38 is right next to the 128. So name those. That is angle CDB. Okay, Jason angles. Angle CDB and angle BDE. Now, here's the nice part when you're naming adjacent angles. First off, the letter in the middle should be exactly the same. Adjacent angles share a vertex. The vertex is the middle letter, so that should be the same. Also, since they share a side, look at this side they share right here. That is side DB. DB, DB. So they should have two letters that are the same in their name as well, with the middle letter being exactly the same, because that is the vertex. Example 2. Now this is where reading and looking at the key information that's given to you is important. Given angle 1 is a complement of angle 2. And angle 2 is 57 degrees. Find measure of angle 1. Well, complement means they add to 90 degrees. If I know part of that 90 degrees is 57, I'm going to simply subtract them to find angle 1. 90 minus 57. 33 degrees is the measure of angle 1. To B. Now, 3 is a supplement of angle 4. Supplements add to 180. If I know angle 4 is 41 degrees, I'm just going to subtract the 41 from 180 to get the measure of angle 3. So angle 3 is 139 degrees. Example 3, a lot like example 1, but this time they want me to name linear pairs and verticals. So I'm going to start with the linear pairs. Now remember, linear pairs form a straight line. So that's what I'm going to do. I'm going to look at my diagram, I'm going to find a line, and then see if there's just two angles that make up that line. So here's my first line right here. See this line? Are there in fact two angles that make that line? Well, there's angle 1 and then angle 2. Angle 1 connected to angle 2 make this a straight line. So 1 and 2 are a linear pair. Now, some people will be like, well, what about the bottom side of that line? Okay, same line. But what about the other side? Are there two angles that make that one? No. Watch this. Angle 3 and angle 5. Because those are the ones that are on the line. If I swing those in, there's a gap missing. Angle 4 took a chunk out of the middle. So I don't have a linear pair. This would actually be three angles that make the straight line. So therefore, it's not a pair. So 3 and 5 are not a linear pair. Look at the other line now. This line right here. On the left-hand side, I have angle 3 and angle 2. See how those two angles right next to each other? They make this line. There's a linear pair. Now, the same situation as before. If I swing down angle 1 and I swing angle 4 up, angle 5 has that chunk out of the middle. So 1 and 4 are in fact not a linear pair. So we are done naming linear pairs from this particular diagram. We're going to move on to our vertical angles. So let's get rid of this purple here. Now we're going to look at vertical. Okay. Vertical angles are formed by intersecting lines. So I'm going to look at an angle and see if there's something across from it. So let's just start at the very first one, angle 1. See, here's angle 1. What's across from angle 1? Across from angle 1 is angle 3. So I like to trace them. Why do I trace them? Look at what I've traced. Here's a line, here's a line. So 1 and 3 are in fact vertical angles. Okay? Now I'm going to erase that, and I'm going to do this again. I'm going to start over. Now I'm going to move on to angle 2. Angle 2, what's across from angle 2? Now some people think, well, angle 4 looks like it's across from angle 2. So trace angle 4. Go ahead. See what happens here when you trace angle 4? There's a straight line right here. Great. This, however, is not a line. So since that is not a line, angle 2 and angle 4 are not vertical angles. Same case, neither is angle 2 and angle 5. They are not vertical angles. There's only one pair of vertical angles in this given diagram. Example 4, the dreaded word problem. Oh no. Read it, look at the keywords, draw a diagram. Draw a diagram, you have now a picture to reference to solve the problem. Two angles form a linear pair. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. Okay, read it once. Now go back, reread it, look at the key words. Two angles form a linear pair. Stop there, that's the first sentence. Draw a picture, linear pair. So I need a line, and I need a pair of angles. So I got two angles that form a linear pair. The measure of one angle is 4 times the measure of the other. What is the other? We don't know what the other is, so we're going to label that x. It's unknown. So this guy is x degrees. I don't know what he is. I do know, however, that the other one is 4 times it. So on this side, I'm going to write 4x. Now the nice thing about linear pair, they make a line, which is a straight angle, which is 180 degrees. So we're going to have 4x plus x equals 180. Do the algebra. Add your x terms, divide by 5. You get x is 36 degrees. Now, again, in this class, it's very important. It says find the measures of the angles. The one angle is 36 degrees because we called it x. So we have one of them. This guy is 36 degrees. To get the other one, simply multiply it by 4. And the other angle is 144 degrees. So my two angles are 144 degrees and 36 degrees. Now, that was quick, that was fast. Again, if I lost you somewhere, go back, rewatch, put it in slow-mo if you want. I might sound a little funny though. After you're done, try these 5 problems on your own, and we will go over these in just a bit.